Okay, so I spent the last bloody 20 minutes messing around with audio and yeah, you can hear that in the background, Beethoven. I'm gonna just record it and see how it goes. So basically, what I'm gonna be doing here is, you know what, screw it, I'm turning off the music. I'm just not feeling it. I'm just not feeling it. I'm not really sure how it's gonna, I want some sort of background music, but Beethoven has just pissed me off. So anyway, I'm gonna turn that off and we're gonna just get straight into it. So I am KDM Stats, in case you haven't guessed, and we are going to be doing some coding today. I've been planning to do some Mastermind, some other coding, other games, board game, AI and stuff like that. You can see here, I've got all my KDM code. This is, the logs will be up at some point when I get 50 patrons on my Patreon. The other stuff, probably not going to share, as said. I don't know why I'm even showing you. I'm just a little bit cruel doing that. But anyway, we're moving on. We're going to create Mastermind. So if you can see my webcam down the bottom left or right hand side of the screen, you can see secret code right there. It's a knockoff of Mastermind. So I figure if these guys knocked it off all that time ago, then it should be okay for me to knock it off as well. So brand new project, brand new repository. I will be committing all of this code to a public repository on GitHub. So yeah, I'll put a link in the description to my GitHub page so you can go check it out. And I think we're just going to do it in stages, and I'm completely freewheeling here. So I'm not really sure what I'm doing, but we're going to start off. We're pretty much just going to make it up as we go. And today is going to be the framework, the absolute framework of Mastermind. So we're not really going to code any of the AI. We're just going to code the framework. I suppose I said that a few times. So I'm going to start off with I cannot do these even choosing package names. I'm just really bad at it. So we're going to have a class named run. We're going to make that a main method, and this is going to be our basic run thing. So I'm not going to do any cuts here. I'm not going to do any splices. It'd probably be a good idea if I did, but I don't have a subscription to Adobe Premiere, blah, blah, blah. So I'm just going to do it as is. So we're going to put all of the stuff in there that does the actual running. So this is going to be the high level, and yeah. So we're just going to be mainly doing types at this point. So we're going to put a thing called types. Yeah, I can't remember if I put type or types, but I think types is generally what we're going to be doing. And we're going to start doing a whole different bunch of things. Now, it's, where is it? I've got the actual game board down here somewhere. So you can see that. That's the game board. So you can see, I don't want to show you too much, and I can't even get the damn thing open. Wow, this is. But you can see sort of there, a whole bunch of little tokens up here. I don't want to tilt it too much because things will start falling out, but you've got all your little tokens, and then you've got your big tokens. The big tokens are what you actually make the code out of at the top. I don't know why I'm explaining Mastermind to you guys. You probably all know it off by heart, or if you're a board game enthusiast, then you probably should know Mastermind by now. So basically what we want to do is we want to sort of design this this game in a framework. So that's what we're going to be doing. So let's see. So you just got to think about it. If you're wondering what that Velcro noise is, I do have tendonitis. I do wear wrist guards. So there you go. Every now and then I adjust it just to make it comfortable. It gets very uncomfortable after a while, no matter how much you adjust it. But hopefully that isn't affecting the noise too much. So anyway, we're going to start off. So we got a choice here. I think I'm going to go with an enum for the different colors. Well, I need an enum regardless of what I do. I don't think I'm going to use the enum everywhere, but I think I need an enum. So types dot, we're going to call them tokens. Is that what they're called? yeah, let's just call it a token. Types.tokens, and it's going to be token color. That's Australian spelling right there, so gotta love it. Types.tokens, and we might put some more information in here later. Green, orange. These are just the colors that are on this particular game. White. Now we might want to add a, it doesn't really matter. So if we might want to add a display string in here for display purposes, but I don't think we really need to at this point. So types.tokens. There are also little tokens for the hit and the, so when you've got a correct color by wrong position or correct color and correct position. I'm not sure if we actually need anything here for that. So we're also going to create a token class. Again, this one's not absolutely necessary, but we are going to do it anyway. Token color. But we probably won't define any of where it is on the board. We'll define that in some other place. So token. No, I do not want to exit. Why would you? Must have pressed something wrong there. This and then we take the easy way out, which is source, generate getters and setters, last member, done. Okay, so we're not coding in the thing. So let's go ahead and start coding in something a little bit more interesting here. So this is kind of, this early stage is where the game, the framework sort of gets made or broken. Basically, if you make a mistake at this early stage, a lot later you've either got to fix it, which can be hard because there's a lot built on top of it by that point, or you're in a ton of problems. So it's nice to get a nice framework. So, and the way I find to get a nice framework is to think about it in terms of the real world. So we'll get the board out again. We can see this, and you just got to make decisions about that. That doesn't help. I can't get my head and the thing in the same point. But basically, you got to make a lot of decisions about this. So you got to make decisions about where do all these little bits go, like these dots here. How are we going to code these? How are we going to code these? How are we going to code this bit at the top? What do they actually look like in code? And if you do it right at the start, then your code goes so much smoother as you go on. If you do it a crappy job at the start, then you're going to be writing complicated code to deal with that crap for a very long time, and it's just not going to be fun. So what we're going to do here is we're going to put it at two different levels. We're going to have a board types. So we're going to have a board, and the board is going to be everything except not where the secret code is actually shown. So if I pull this up here, the board is going to be this section down here across. So these 4 dots and these 4 bits doesn't include the secret code. So this secret code is not part of the board. That's just a tangent somewhere else. So we're going to put the board out here, and we've got, let me see, we've got 10 rows. So I am just going to, we're actually missing, we need a thing here. So we're going to do another thing. And this is the kind of thing that makes things easier. So instead of having, like, you could have a two-level array, or you could have an array in an array, or you could have a list of a list of a list or something like that, and that's how you could store all the combinations. I don't want to do that. That makes things complicated. A list of a list is just, I'm not going to say it's bad coding, but it's bad coding in this instance. You do not want to do that. So here, we got another decision to make. We could have a list of tokens. Do we want to do that? The other option is we could have like token 1 like that. And then we have token 1, 2, 3, and 4. Now, token 1, 2, 3, and 4 is neater because you've defined that there's always going to be 4 in there. That's nice. It's always nice to constrain variables if you can, but we don't want to use that. I prefer the list because if you have a list, then you can do stuff a lot easier, like figuring out, is there a yellow? If there's 4 different variables, that's a pain in the ass. But if it's just a list, then figuring out if there's a yellow in there somewhere is a lot easier. Why? Save. Where's my auto input? Oh, god damn it. I hate it when this happens. Maybe if we get list first, and then we save. I've saved token, public class token. I don't like it when it does this. Board, maybe we're going to save that. Yeah, Eclipse is a bit funny sometimes. Public combination list token. Now this does obviously open up the possibility of passing in an invalid number of tokens. Here we go. There's the input I was looking for. So what we do here is we're going to say if tokens dot size not equal to 4. Now here we need. I like to have a bit of. Actually, what I usually do in the KDM code is I have a custom log handler that obviously writes all the logs out as you're doing it. And what I would do here is I would just call log handler dot crash, and it would crash and it would print out all the logs, because I don't always print out all the logs if I don't have to, if I just want the stats, but I would just crash here. So what we're going to do is we're going to create a crash handler here, just because, I mean, you throw exceptions, and exceptions are great in certain circumstances where you don't want to just completely fail, but this is not going to be a huge application. So I think just completely failing here is going to be fine. So let's go ahead and just call it crash handler. We're going to have logs, something like that. So let's put a logs here. Yeah, crash handler. Though, if you may be wondering, the reason why I had a separate logs project for the KDM sim was because I needed to release the logs out publicly while I wanted to keep the rest of the code private. Definitely for this, it's all public, so they can absolutely be in the same project. So crash string message system.exit. Now we're going to put some other stuff in here to actually handle logs. We might as well do that now. And putting in logs is, I'm not going to say it's 100% important, but it's a simulator. Like, you want to know what's happening in the game. You don't want to just run it and say 70% or something like that. Maybe sometimes you do, maybe sometimes you don't. I don't know. So anyway, the crash. What we really want this is to be is the log handler. So we're going to create another log handler. We're just going to make this a log handler, and then we'll still have a crash method in it. So private boolean print logs equals false. Public log handler boolean print logs. And then I don't think we need a particularly fancy log framework. I think we just need some logs. Now I'm getting ahead of myself here. I'm sort of going off the framework a little bit, but trust me, this is going to be it's going to be nice later on, because we'll just have it log message. string. And we want I want to override this guy as well. System.out.println. Just a nice little indentation there. What are you complaining about? Oh, that's right. I'm creating a toString, aren't I? Whoop, that didn't work. Thank God for the undo. So then we can just, go through and just print them out directly later on without having to do any faffery with the internal message. So go back to here, private list log all logs. Don't have to worry about anything really crazy. We're going to have one game at a time, and I'm not sure if, well, we may have to change this later on if we're going to play multiple games and if we've got multiple logs per game or something like that, blah, blah, blah. I'm not going to worry about that now. So anyway, all I want to do is for log all logs, system.out.println log. And because we got the toString in there, that crap will just work. And then, so we crash here. Now this is a bit of a tangent. That'll be used later on, but yeah, so we do need that. But anyway, log handler.crash. I forgot to make that a singleton. All right, let's go back to here. Static. It is a singleton, but this isn't a thing. So private public. How do I do a singleton again? Log handler instance. Get instance if instance equals null. That kind of screws up our print logs. I swear to God, it wasn't a singleton last time when I wrote it for KDM. I'm gonna have to go back and look at that, but I'm not going to go back and look at it now because, as I said, trying not to show that code. Although I think that's the logs code, which I'm going to be releasing at some point, so maybe it's okay. Handler, log handler. You are an instance. You're definitely an instance. Ah, yeah, see. So every time I start a new fight, I get a new battle log, and then the battle log contains all the logs for all the under ones. So that's how I pass in all these things. Not going to be able to do that this time because we don't have logs of logs. We will eventually, but whatever. So let's just do it for now. What are you complaining about? Maybe we should just get rid of this and then public void set print logs. No, that's not what I had. Boolean print logs. Okay. That's all right. I'm doing crap that I don't even care about anymore. Crash. So to set combination with tokens dot size tokens, and then we print out the whole of the tokens array just so we have it. Log handler dot get instance. Now we can't just make this a static method. I suppose we could, and then logs, just make sure that's getting the right log handler, not the one. static reference. Okay, 3, 2, 1. Sorry about that. I accidentally hit the F3 key, which is my start-stop recording. I'm not sure why. I'm not sure why my fingers are up there, but I'm going to have to keep an eye on that from now on. I should be able to just concatenate these videos, and yeah, it should be good. So anyway, all I did since then was go back into the log handler, make some stuff static, and add these. So now our combination class is pretty much good. Board is going to have a, so we got a combination. We might want to abstract it a little bit more as well, because we got a combination, and I think I want another class as well. We'll call this one evaluation. So this is going to be private int let's just say white pin and red pin. Because I was going to say correct color, wrong position, but that's just a very shitty variable name. So source, generate constructor using fields. Why is it always put it above the variables? I hate it when it does that. Okay, source, generate getters and setters, select all, last member, done. So evaluation. So I guess the best thing to do here is combination evaluation. Board contents. Now this does leave us with the somewhat overhanging possibility of when you put a combination down, then yeah, you haven't evaluated it yet, but technically, I mean, you're playing as the AI. So as soon as you lock the combination in, okay, the computer evaluates it for you. So I don't think that's too much of a problem. Turn, and then, so I'll make this a new hash map. So board. So I think that's all we need for this one. So public board. Now this one doesn't need to know about the secret code. We weren't going to put this in the board. So all we need to know is this dot turn equals 1. Turn equals 1. So that's going to be fine. Let's start putting in some methods. Next turn. God damn it. Plus plus. I don't know what else we need at the moment, but if turn equals 10, it's game over. This is not really a crash, is it? You know what? We're going to check turn somewhere else. We're going to make sure that we don't increment the turn if it's already turned 10. We'll check it later somewhere else, which means that if it does somehow manage to get into this code, we are going to consider it a crash. God, how I just cannot type. To increment turn already turn 10. Now, if we want to, we could be max turns. We could be very fancy like this. Actually, I like turn limit instead. If turn equals, there we go. Private int. Now this is one of those things where I mean, the game's simple enough, so we can do crap like this if we want. If we want to play around with increasing the number of turns later on, or trying to limit the AI to doing less turns, it might be interesting. So anyway, we've got this. We've got combination into evaluation. Okay, so pressed F3 again. I swear to God, this is the last time, okay? It's done now. I've gone back into XSplit. I've reconfigured it so that when I am in another application, hitting F3 does nothing. There's no way that I can stop the video now, so it'll never happen again. Apologize for that. So I actually skipped about 10 minutes. The first time I did it, I skipped like 10 seconds. This time I skipped like 10 minutes. So, it's bad. But I'm looking at it, and we stopped about here, and we went on and we did a bunch of different things. So after the board, we went and we created the game. Not much going on. The major thing was a turn limit parameter, which we passed through. And then we created a couple of controllers. So basically the controllers are the things that actually run the game. So we've got here the game controller, basically going to be, has an option of the game, so object of the game. And this is going to have all the methods that run through the game and actually run the game. Then we've got this secret code controller as well. This is the guy that controls the secret code inside it. And we've already chucked one method in here, which is evaluate combinations. So you give it a combination, it tells you how close it is to the secret code. And I'm so upset that I bloody blew away all those files. But what am I going to do? Delete the code and then write it again? I'm not going to do that. I'm not going to do that. And I hope I didn't miss anything else or screw anything else up. I think that's it. So the board's the same. The game's pretty good. We're just going through the run. So we're going to, we added a bunch of variables as well. So turn limit, we're going to try and control everything from run here. So we got turn limit. We're also going to basically pass in the secret code all the way from the run method, because that's the way that I like doing it. I like being able to just mess around with things in run. I don't like having to jump over to all sorts of other bits of code. Yeah. So where we were just before I realized that I'd stopped recording was we're about to create a utils. So we're going to create a utils and secret code generator. I don't know how long this video is going to be, but it's pretty long already, but we'll just see how we go. So public static combination get generate random combination. Okay. Yes, I've got that. So we want a list of tokens. For int I equals 0, I is less than 4, I plus plus. Why is it, for some reason it just doesn't like knowing about the token class. Like, there it is, okay, that's fine. So we need a way to get a random token color. Now this is an enum. I'm not sure if there's a way to get a random enum. Ooh, I don't think so. Okay. So we need a random number generator, I guess. Math.rand. Now this will obviously it'll be a little bit interesting. Times 8 int id equals math.random. So this will generate a number between 0 and 7. Double cannot convert from double to integer. Okay, so that's fine. Okay, so that's 0 to 7. So tokens.add. Oh no, what we want to do here equals token color dot values ID. Technically this is an index, not an ID, so let's call it index equals new token No, not. Actually, yes. Yeah, okay, we'll do it like that. Now, what I want to do here is Boolean allow duplicate colors. Because some games, you know, if you play a game, sometimes you allow duplicate colors, sometimes you don't. So if tokens.contains, if it already contains that token, and not allow duplicate colors, I minus continue. So this will basically just move I back and go through and try and do it again. We could get into an infinite loop here if this doesn't select 8 values, if it only selects like 4 or something like that. But I'm pretty sure that's not going to happen. I'm pretty sure this should be fine. Okay, so tokens.add token, return new combination tokens. Okay, so I have to worry about that, but that's very, very unlikely. Secret code generator dot generate. We're going to start off simple, so we're not going to allow double stuff. So there we go, secret code. We got a controller here. Controller dot. We'll create a run method in our controller. Create method run. Now we get into the meat of it. So we've got most of the framework. We've got our secret code controller. We've got our board. We've got our combinations. We've got all of this stuff going on. So, what time are we? I have no idea. We're probably at like 20 minutes. I think I'm going to keep going, and we're going to start to do. What I want to finish off at this episode is a game where you can play and actually play it against, you know, the secret code controller. So they generate a secret code, and you can type in letters. And basically the different letters you type in correspond to the different codes in the different order, and you can play it like a normal Minecraft game. So, okay, so here's what we're going to do. Let's start from the ground up. So we've got the game, we got the board. We didn't really need a game, to be honest. We'll keep it in there though, but it might just be a extra level of abstraction. That do we really need a game and a board? Because the game was going to have a secret code, but then that just turned into a secret code controller. So I'm not sure we really need the game anymore. We don't even have turns. Turns is in the board. Yeah, this is. I'm just calling it here. This is just a waste of time. Whatever. So game controller. You now have a board. You don't need a game. I might regret that later on, but for the life of me, I can't think of what we actually need because the secret code was the only thing we needed in between the board and like above it, and we don't need it anymore. So screw it. We'll just have the board. It'll make it a lot easier because we won't have to go through multiple levels. Okay, so next turn. So we're not gonna put any craziness in here. This is going to be this board should work exactly the same with an AI or with a human controller. It should be exactly the same. So, so we're going to do public void. So we got next turn. Set next combination. Let's just call it new combination. And we do have that problem where we don't want. I think when we do it, I don't think we need to be in a game state where we've set the new combination, but it hasn't been evaluated. I don't think we need to be in that state because the secret code controller can just, boom, tell us. straight away. So I don't think we ever need to be in a state. As soon as we guess the combination, we'll figure out the evaluation before we even get to this. Now, I've just seen a problem here. This is going to be a problem, because what if you have duplicate combinations? I mean, you're never going to guess the same thing again. That's just dumb. But we, I don't think we want. It's not a. It's just not a nice. I don't think it's a nice way of doing it, so we're going to do this, which turns out that it turns out to allow this anyway, where you can put a combination in before the evaluation. A value, oh god, damn my mistyping. Okay, so anyway, there we go. So combination dot put. Come on, typing put turn and then evaluations dot put. Come on, why did I call that the same thing? Put, no, god damn it, it's evaluations. It's got an S on it. Why does it keep thinking it's an evaluation object? Oh, because I changed the name of this one. Why did I do that? I'm shooting. It's just evalu. Oh, God. Damn it. I should probably not be swearing, but this is how you code. You code and you just do your head in by coding. So this is, we could tie these methods together. I'm not going to do that. We could also put null checks here. Just to be on the safe side. I don't know. I'd like to be a bit more protective in this method. Trying to set a null combination onto the board. Especially once we get the AI going, there will be wacky stuff that happens. You might end up with a null somehow getting passed in, and we want to make sure that it definitely gets caught here, because it might not get caught somewhere else. So anyway, game controller, run. Board. So how do we need a method here. Boolean is final turn. Turn equals max turns. Okay. I think I changed this to, did I change this to turn limit? I can't remember. It's one of those things where I remember doing it, but I remember incorrectly, and now in the run method it's like turn limit or something like that. Anyway, max turns, I'll change it to turn limit. This is totally not, engrossing YouTube footage, but whatever. I like things to be nice. I like them to be nice. Okay, so is final turn. Let's get stuck into the game controller. While a board dot is final turn. I don't really like while true loops, to be honest. But then again, I think this is going to be a while true loop, and just hopefully we don't do anything crazy. So down the bottom, we're going to say if board dot is final turn. If that was your last turn and you have it 1, then you lose, which is return false. Boolean. So here we're going to board.increment a turn limit, or increment our turn. Sorry. So this is going to be the end of the while loop. Okay. So what do we want here? Let's put some pseudocode out. Make guess, check guess. So guess correct equals secret code controller. Dot evaluate combination. So turn guess combination equals get guess input, which is our thing for the human input, and that's basically going to be it. Guess correct. Well, that's an evaluation, isn't it? Evaluation. Okay. If evaluation dot get red pin equals 4, return true. And then otherwise board dot add next combination, turn guess, evaluation. Okay, so brilliant. We're gonna also need some output here so we can actually play the game as humans. So system.out evaluation. Now this guy needs a toString as well. Generate toString. That's fine. I don't want to mess with that or make it anything special. That's fine. Guess input. So this is going to be our human readable. So if we go to token color, I want to make this as simple as possible. So no, save. Okay. So the only problem is pink and purple. They've got the same letter. So what do we do here? Well, we can work with that. So red, yellow, green, orange, pink, purple, blue, white. Okay, that's doable. So string input equals system.in dot read. This is reading an integer. I forget how to read a string. Excuse me for a second. I'm just going to go Google Java system read string from input. Read a string from console input in Java. They're using a scanner. Okay, I'll use a scanner. Okay, it seems like the standard way of doing that. Next line. Excellent. So we don't want to worry about spaces in between. So, or do we? We'll make it slightly easier if we have spaces, or if we don't. I don't know. I'm going to say no spaces. So let's use the. Let's first of all refactor this to just be called secret code utils. And did that get rid of some? No, it didn't. Control Y. Okay. where was I? Game controller. So, combination return secret code utils dot parse user input. So this is going to be the annoying code, as you can probably guess. I should go back here. While input string dot length is not equal to 4. So just in case you accidentally type the wrong thing. We'll test this all out in a sec, but it's pretty much, yeah, heavily front loading the code. Why is this? I thought I created that. Parse user, why did it not recognize that? Is that like one character off or something? No? Whatever. Parse user input for int I equals 0, I less than 4, I plus plus. Okay. Do we want a character or a string? I'm just going to deal with strings because I don't like dealing with characters. String ID equals input string dot substring I plus 1. We have to do this again. Tokens equals I know I'd bloody make it all correct, make it parse ID and then I'm mistyping everything, I swear to God. Tokens dot add token. Return new combination. Okay. We don't have to worry about duplicates here because it's all user parsed. So we go back to the game controller. Actually, I'm going to print out these things. Just so when we're actually running the game. Oh, we can't use this. What was I thinking? Purple. Let's make it U. Token color. And what I actually will do, right at the start of the video, I thought about making something here. So let's do it. Public, no, it's a private, isn't it? Private token color ID. This will also make it easier for matching. Okay, why are you complaining? Yeah, that is a variable. Why are you complaining? It's probably because it's not in here. It's probably because that isn't a freaking... There we go. That's now it's got it correctly. Red, yellow, green, orange, pink. Still recording happily. Yes, yes we are. Such a pain in the ass, but you know. Green, orange, pink, purple. I like you for purple. It's not bad. Let's just do a sanity check here. RYGOPUB. No duplicates. for token color TK. I'm just over it. I'm over properly naming variables. I'm just now you can do value of, but value of will work if you pass in red. It doesn't work if you pass in R. That's our variable, so it doesn't have any idea. If TK dot get, we need a get ID here. Public string get ID TK dot get ID dot equals, ignore case just for the hell of it, and return TK. And we're going to do another crash log here. Crash could not find token color with, actually, you know what? We don't want a crash log here. Because that means if we mistype, then the entire game will crash, which is not good. So, token color. If token color equals null, return null. So we're gonna handle this nicely this time. Parse user input. What are we doing? So we're going to do here. And then we're going to say there. So basically, we're going to keep asking the user again and again until they get it right. Input string equals. So while it's not equal to 4 or blah, blah, blah. So anyway, that's beautiful. Okay. So we got that. Game controller. Why are you? Scanner is never closed. Okay, we better close that then. Okay, we might have a working game here. So what I'm going to do here is I'm going to test it. And to test it, we need to know what the secret code is. Do we have a toString on the secret code? No. Generate toString. I think we got a toString on the token. No, we don't. Source. Generate toString. I'm just going to put toString. And then token color, we can make a toString here. What do you mean it's not applicable to enums? You piece of crap. I'm going to make it applicable to enums. Oh, wait, what am I doing? Why am I wasting my time here? Let's just go color dot get ID. That's much simpler. Okay. So we run. That's not the right run. That's the KDM run. Let's run this. Let's just so I don't confuse this. Let's refactor. This, yeah, whatever. Mastermind run. I think it's 2 words actually. Mastermind. Okay. All right. First off, for usability, game controller. I'd like to have system.out.print just so I know when I'm supposed to be typing. So RUUP. So if I type in RRUG, I get a null pointer exception. All right, this is why we run the game. Evaluation.getRedPin. So that's telling us that evaluation is null, which is because we never filled in this method. Okay, done. This is good. Okay. All right. So this is probably the most complicated thing we're going to do today, but that's fine. That's fine. I think I'm okay with doing a little bit of complicated stuff today, instead of just framework code everywhere. So combination. Okay. So what we're going to do is int red pin count equals 0, int yellow pin count equals 0. Combination is everything is a thingamabob, is a list. And we're gonna do some helper methods in here now, because I think we need some public. Before I go into help methods, let's just set this up first. So for token, what are we doing? Combination secret code. So I want to have this as a map. I want to convert this as a map. Now, technically, this map is never going to change, so we're just going to set it up here as part of initializing the class for int I equals 0, I less than 4, I plus plus. Now this is where you can really get in trouble, because you start to forget your IDs, and I was about to put this in as 1, 2, 3, and 4 as the keys of the secret code map. You don't want to do that. You want to keep 0, 1, 2, 3 everywhere you can, because it'll make indexing and all that sort of stuff, list manipulation, a lot easier. So this dot secret code map dot put let's see, I secret code dot get tokens dot get I, and this is why I love using lists everywhere, because you can just call get I. Okay, so secret code map. We now have the secret code map. Why are you orange? I don't know. We should probably make this a new array list and then clone it here. Not super necessary, but I like doing it. There are some things you don't want to clone, like if you've got for example in KDM I got a survivor that I pass around. You don't want to clone that, because then you lose track of it. I don't need to populate it there if I'm populating it here. And that's a combination. What the hell am I doing? I have no idea what's going on here. Well, I'm not going to clone a combination, even though it has a list in it. I mean, that's just too much of a pain in the ass. We could figure out a way to clone it, but I stopped caring once I realized it's not a list. All right, so going through the map for entry. So we're going to use the entry set out of this, just so we have access to both of the things that we want, which is A, the position in the list, and B, the actual thing itself. So we need both of those. So evaluate combination. Combination dot contains token at index. I guess index works. Entry dot get value entry dot get key. No, got dot get key. It's I had it highlighted because it was on my mouse or something like that. Okay, that's an actual if statement, so we don't need a semicolon there. Red pin count plus plus. Now we might have to revisit this code if we start working with duplicates, because I don't know how well this code is going to work. I suppose it's not at any index entry dot get value yellow pin count. Okay, so we'll come back to those methods in a sec. New evaluation. What order are these again? Yellow pin and red pin. They should probably be the other way around. Just because that's the way the game's played. It's always the red pin first and then the yellow pin second. Now we can change these as well. I'm not going to go so far as to change the method orders, but I am going to go so far as to change this. Whoa, what did that just do? I hate it when it does that. And we need a... that was doing some weird stuff. Yellow pin. Okay, I think that's good. And you know what? I'm going to change it because just so it makes me feel better. Okay, just want it to make me feel better. New evaluation, red, yellow pin count. All right. So let's create these two methods. What are you complaining about? Now, I almost forgot. We do have some string manipulation, or not string manipulation, but stuff here, tokens.contains. So we need to make sure that the token can handle that. Because by default, if you try and equals or contains or hash, put them into hash sets and expect them to be equals, it just will not work unless you have both of these methods, or at least the hash code. The equals is nice as well, but we want to make sure we have the hash code. And well, that opened a crap load of stuff. We don't want to do that. Go away. Just go away. Where's my enum? I don't think this needs to worry about hash code and equals. I think it just deals with it. We will find out anyway. So we're done with that. We went into we're in the token. No, we're in the combination. Combination. Okay. So we need to figure out these methods. This one's not too bad. Tokens dot contains. Call this token. Index. Get index dot equals token. Okay. Now we should be all right. Let's give this one another run. Evaluation, red pin 1, yellow pin 0. Okay, so that worked. And then it threw in an exception. Why'd this throw an exception? Guess input. What's wrong with that? We're just creating another scanner. This is going to be one of those problems that's a pain in the ass to find. Maybe there's something wrong with creating another scanner. I mean, we're exiting out of the method. No line found. All right, I'm going to have to Google this real quick. Scanner, Java, no line found. Okay. Oh, maybe I don't like this while loop. Maybe this is all going crazy. Maybe this code is just bad at this point. I'm not really that sure, but this is one of those things that usually takes me about 15 minutes to debug, and I really don't want to do this on camera. But basically what Google is saying is that you have to check that there is another line before you can go onto it, which is crazy because yeah. Okay, you know what? We're gonna get rid of this. We're gonna get rid of it. Screw you, buddy. I don't care. Why? Okay. GOPS. Okay, now something's going wrong. Although, maybe it's working, because I'm typing in crap, so PPPP. Okay, it's working. It's evaluating. The cursor's going all over the place. Stop. How do we stop? Okay. We need some way of saying, okay. Let's keep this. Error. System.out. Invalid input. Okay, let's try that. Now I am creating a memory leak by not dealing with this scanner. Well, no, that's the wrong run. It's the wrong run. You might be able to hear my computer just screaming there. I started running the KDM. So there we go. YPG, exception, out of bounds, secret code, pass, user limit. Okay, let's do this. Trying to make this as user-friendly as possible because, of course, this code is going to be released to the masses. So let's try and make it as user-friendly as possible. Invalid input, mastermind run, invalid input, PUOF, invalid input, PUOR, evaluation. Okay. We are in business. PUOG, and then we terminate. So let's go back to the mastermind run. Boolean win equals if win system.out.println win, else system.out.println lose. Now all we need to do is we need to go to the board and next turn system.out.println, just so we have some idea of where we are in the game. Turn limit. That's a bit better. So now we run. No, I hit the wrong run again. God damn it. Okay. Mastermind. Yeah. Stop. I'm going to paste that there as well. Okay. Mastermind run. Why is that? Shouldn't that be printing out before the... Oh, that's the secret code. Sorry, that's the secret code. So, of course, that gets printed first. Game controller. System secret code. Okay. God damn it. I know. Let's fix this up as well. Combination. We don't need all this crap here. That's a bit better. YOGP. Red 3, yellow 2. OYRG. I just realized this spells orgy. Red pin 0, yellow pin 4. Okay, that's good. YOPP. 2 and 0. OYPP. Okay. All right. I think we're pretty good. Let's just do a final test. 1 7 8 10 9 lose. Okay, so it sounds like we've got a pretty good game going on. Okay, well, I think BUP. I think that's going to be it for now. So we've got the framework, we're able to play the game, and yeah, very happy with that. Took a long time, had some annoying XSplit cuts where I accidentally hit the F3 key, but whatever, we're done, we're dealing with it. I'm going to go ahead and I'm going to push this code up to GitHub right now. Maybe not right now, but in a little while. And yeah, then we will be good to start implementing the AI. So basically what's going to happen is this, this bit, guess input. We're just going to replace this with another controller. We're probably going to pass the board into that controller, and the board's going to take a look at all the evaluations for all the turns so far, and it's going to figure out what its next guess is. And that's going to be the AI part. So anyway, going to get into that. Yeah, so this has been a long part 1, but the framework's done. Thank you very much for watching, and I will catch you guys later.